Hey, this is René, and in this video I want to talk about include files in the MetaTrader 5 and how you can use them to create strategies to test in very short time.
This video is presented by BM Trading. Learn to code your own expert advisors. Link in the description.
So what I want to do is I want to help you or show you how to write a code for a include file, which is a MQH file in MetaTrader 5, and then show you how to use this file to build an expert advisor. So let's just jump into it, creating a new include file. You can click in the meta editor in the upper left corner on new, and then click on include, and then next, and then you have to provide a name. For example, you can say my library, because this will be a library which contains all of your useful functions that you can use to create your expert advisors and strategies very quickly. Then you click on finish. So what you can see here is this include file. It looks a little bit different than the expert advisors that I normally create in these YouTube tutorials. So what we can see here is we have a bunch of comments, and yeah, this is actually not really important for our program. And then we also see a few properties which are also not important. So you can see even if the include file is completely empty, I can compile it and there's no warning or no error or anything. This is because an include file in MetaTrader 5, it is not designed to actually open or close trades or respond to chart events or something. An include file is more or less a blank file, but it can be used and it can be included in other files to have access to the source code in this include file. So what this does is, let me add a little comment here for me, because I want to do a few things here in this include file. So what we can do here is we can write a function, for example, in this include file, and that's what you usually want to do. You want to put functions there, or you want to create a class, for example, in this include file that you can use in multiple of your programs. So if you have a task that you do very often, then you might want to put it into one of these include files. Like, for example, we could say we want to have a function that recognizes flags in the chart. So let's say, for example, the price was going down for 1, 2, 3, 4, 5 bars or whatever, and then there's a green bar after this. This is what I would say is a flag. I mean, there are different definitions for this, and your definition might be different, but this is not what the topic of this video is about. In this video I want to talk about how include files work. And here again, another example: 1, 2, 3, 4 candles go up, and then one candle goes down. So this is what I want to check in this include file, or in this function. So what I could do is, for example, I could say int check flag, for example, and then I want to have a bunch of, or at least one parameter, the amount of bars I want to look back, because as I said already here, we want to look back x bars. So we could say we want to have 4 bars going up and then 1 bar going down, or we want to have 3 bars going down and one bar going up. So this is what we want to check. So for this reason, first of all, we can check, for example, if bars is smaller than 2, and then we just want to return 0, because in this case we cannot really check anything. But if bars is at least 2, then we can check something. And bars is the amount of bars that we want to check. So what we want to do next is we can create, for example, a MQL rates array, which I can call rates, and this array will have the size of bars, because I now use the copy rates function to store the rates of the last bars inside of this rates array. Here I can say, for example, period current, or I could also say I want to have the period as a parameter here. And this is what I would suggest if you create an MQH file and put some functions in this MQH file. You should make these functions really flexible. So if you use this in a bunch of different programs, you can really make it specific for the program that you want to use this function in. So for example, I could create another input here, time frame, for example, and then I say I mean, I could also define the symbol, and you can do this if it's useful for you. I often just hard code the symbol also in my include files because I mainly work with the chart symbol. But yeah, I mean, like, you can also put it here, for example, like symbol, and then it will take the symbol here from the input list or from the parameter list. Then we have the time frame. Then we have the starting position. Here I would just go with 1, and the amount of bars is that we want to look back is defined here by this bars parameter. And then we store the amount of bars in our rates, or we store the bars in our rates array. And what the MQL rates structure does is it can hold a time, a open, a high, a low, a close, a tick, or a volume and a spread for every single bar in the chart. For example, if I define it like this and bars is 4, for example, we would start at the last bar because I said index is 1, and then we will take this bar, this bar, this bar, and this bar, 4 bars in total, and we will store the high, low, open, close, and the timestamp of all of these bars in our MQL rates array here. So this is useful, so now we can work with this. And yeah, also what we should check maybe is if this copy rates function returns as many bars as we want to have. So we can check if count smaller than bars, for example, we also want to return 0. But yeah, if we find at least the amount of bars that we want to find, then we can check here if we have a flag. And for this reason, we first of all have to check the last bar, and we check, for example, if it is green, and then we have to check the previous bars if they are red. Or if the last bar is red, we check the previous bars if they are green. And this is very, very simple. Or yeah, I mean, we can only have a flag in one direction, which means that we can use Boolean variables here and make them true or false. If it is a bullish or a bearish flag, we can say is bull flag is equal to, and then we can say rates. Yeah, let's maybe make this a series array set as series, and then we say rates true. We could also make this here, or yeah, I mean, it doesn't really matter. And then we can check the last bar, which is at index 0. And we don't really have to check if this index is available because we checked it here and here already. So it has to be available. And then we can check if open is smaller than close. Because otherwise, if the last bar is red and not green, then the bull flag is immediately false. And we can check if is bear flag. In this case, we check if rates open is greater than rates close for the last bar. Okay, once we figured this out, now we have to loop the rest of the bars. So what we do here is we have to make a for loop, of course. We say int I is equal to 1. And as long as I is smaller than array size rates, then we want to increase I. So here, yeah, let's check if rates at index I open is smaller than rates at index I close, which means that at index I there is a green bar. In this case, we can say is bull flag is false because we want to see red bars now. And if rates I open is greater than rates I close, then we say is bear flag is false because here we do not see any more red bars. So this should actually be it already. And now we can say if is bull flag, then we want to return 1. If is bear flag, we want to return -1, and otherwise, if we do not have a flag at all, we want to return 0. So this is a very generic generic function to check if there is a flag in the chart. So why do we do all of this? Of course, we don't do it to just create functions randomly. We want to use this in one of our programs. So one example would be, for example, to create a new expert advisor. So click on new in the upper left corner again, click on expert, click next, and then we can say flag trader. I create this for YouTube. So I create a flag trader YouTube program, and then I click next, next, and finish. And this will create an expert advisor for us. So I talked about expert advisors a lot on this YouTube channel in a lot of my videos. So what expert advisors do is they actually trade. And this is why we do see these event handling functions here. Let me rearrange the code a bit. I may make this a little bit bigger. So what happens here is if we create expert advisor like this and we do have these event handling functions, everything is fine. But if I remove these event handling functions and have a blank file, as I just had for my MQH file before, if I compile now, we get a problem because we see there's no event handling function. So this means that this expert advisor is pretty much useless because expert advisors are designed to run in a chart and to react to specific events, and this is why you always need to have a event handling function in the expert advisor. So if I get my event handling functions back, we can now say, and this is the cool part about include files, we can say this hashtag include, and then in brackets here you use these spiky brackets like smaller than and greater than if the include file is located in your include folder. And here we have to talk about folder structure a bit in the MetaTrader 5. You can see in the navigator you have a bunch of different folders. For example, here we have the experts folder where we can find the expert advisors that we created and where we have the source code of. So for example, here you find the flag trader YouTube that I just created, and it is this exact file. And then if I go to this include folder down here, we will find all of the include files. For example, we will find my library file here. And if I click on this, you can see this is the file that I just created before. So include files are always, or by default, located in the include folder. And expert advisors are located in the experts folder. And this is the standard path for your include files, and this is why with these spiky brackets you can reference files in the include folder. So if I now say my library is the file name, and if I compile, you can see this works, and now in the toolbox here we can see my library.mqh is now part of this program here, which is very, very cool. We could also put the my library.mqh file in the same folder as the expert advisor. In this case would be the experts folder, but then you have to reference it using these quotation marks. This doesn't work now because the file is not located in the same folder. But if I, for example, go here and go to the includes folder, and if I take this file from here, wait, let me close this. So if I take the my library file from here, if I let me for example copy it, and if I now put it into the experts folder here, where also my flag trader is located. So if I put it here in the same folder, you can now see my library on the left side is in the same folder as the flag trader. And now if I compile, this works, because now I can use these quotation marks if the include file is in the same folder. But again, if I remove it from here, it will not work anymore. And then if it's only located in the, or if it's located in the include folder here, then I use these spiky brackets. Okay, so this is how to include a file. And now we can actually just say in the onTick function, for example, we can say if, or we can just say int flag is equal to check flag. And you can see now we have to provide the symbol, underscore symbol, the time frame. Yeah, now I will just use the default values here, symbol, period current, and the bars, which I can say, for example, will be 4. And if I now print the flag, you will see what happens. If I compile, it works. There's no error. Everything's working smoothly. Even though the check flag function is not part of this file here. but it is part of the my library file. And since I included it here, you can see this include line as the program pretty much checks this file and takes everything inside of this file and just puts it here instead of the hashtag include my library.mqh line. And that's pretty much how you can understand include files. So if I now compile this, and if we go to the MetaTrader, I can open the strategy tester here by clicking on view strategy tester, and then I can say I want to check my flag trader program here, test it in any chart, it doesn't really matter, in the visual mode. And then if I click start, you will see that if I have a look at the journal here, it always prints 0 or 1 or whatever. Yeah, let me check if there's a if I can find a flag. Yeah, you can see here, for example, the last bar now generated a flag, a negative flag, a bear flag, and you can see last bar was going down, the previous bars were going up. Actually, there was not really a tick, so maybe we don't want to include this. So maybe we should say here in the my library file, we should maybe say if it's smaller or equal or greater or equal, then we want to make it false. But yeah, this is like the general logic of how to include a include file and how to make use of it. So you can see it's very, very cool, because you might want to use this check flag function in many of your programs, and then you can just include the my library and then use it like this. So it's very easy and convenient because you don't have to write the function every single time. And the second huge benefit is that your MetaTrader program or the expert advisor, it looks very, very clean because you don't have a bunch of functions here, and you can use less lines of code to write a program that does a lot, and you pretty much still understand what it does because the name of the function pretty much says what it does. Or you can also check for bull and bear flags. You can also add comments like this, and now you have 2 lines of code instead of, I don't know, 30 lines. So that's very, very cool. So let me show you some more examples. And also let's make sure that this only happens once per bar, because otherwise it's a little bit messy. So what we can do here is we can say, for example, static date time timestamp, and then we can say date time is equal to I time symbol period current 0. And then we want to do this only once per bar. So we check if timestamps unequal time, and then we say timestamps equal time to update this. So now we only check this once per bar, so we don't take too many resources of our PC. So in the my library file, we can add more functions now. Let's so the flag is already handled. Let's say you want to have a MA or a moving average filter, or a filter for pretty much every indicator. And here we can create a moving average filter in our include file, and then we can use it in all of our programs. Let's say, for example, MA filter. Or we can say check MA filter. I mean, it depends on how you want to name this. There's not really a right or wrong, but we can create this. And what we want to do here is we just want to check if the moving average filter is positive or negative. And let's just create a normal moving average filter. So what we have to do here is we have to create a handle for our moving average using the IMA function. So let's put some default values here. SMA price close, and I will tell you why this is not really a good idea or a recommended idea, I would say. But yeah, let's start like this, and then we can say count is equal to we say we create a array for the values MA, and then we say count is equal to copy buffer handle MA buffer number 1 or main line, because there's only one line, and then we store the value in the moving average array, and then we can check if count is smaller than 1. And then we say if it's smaller than 1, we return 0, because then we cannot really check for a moving average filter. And then we check if, or let's get the bit price, symbol info double, symbol bit, And then we check if bid is greater than MA at index 0, then we want to return 1. If bid is smaller than MA at index 0, we want to return -1, and otherwise we want to return 0. So this is the easiest implementation for a moving average filter. So let's now use this in our program. Here we can say MA filter is equal to check MA filter. And now we can say, let's write a comment here, flag, or we can say flag is equal to flag, and MA filter is equal to MA filter. Or we just print this in the chart. So how this looks like is what I will show you now. So if I start another test, you can see in the upper left corner, we now see currently MA filter is -1 because the price is below the moving average. And we don't see a flag. And now we do see a flag because we were having 1, 2, 3 bars up and 1 bar down. This is the minimum requirement for a flag. And also the moving average is negative. So you could enter a short position here. And let's see what happens if we go above the moving average. Dang. I was too quick again, but I think if I would not go this quick, we could see that if the price is above the moving average, yeah, here you can see MA filter is now 1. So our moving average filter is also working. But there are a few things that are not very clean here. The problem is that first of all, we create this handle every single time the check MA filter function is called. And this is not really recommended programming. It's not really good because the creating the handle, it takes quite a lot of time. And if you have a look at, for example, the I don't know if you see it here in the reference. Yeah, it's usually recommended to do this in the onInit function of your program, like create the handle here. So what we can do to not make it with every single tick or every single call of this check MA filter function, we could make this a static variable. This is one solution because in this case, this will only be processed once when the check MA filter is called for the first time. There are still some downsides. For example, if you use this in a normal chart and if you change the settings, it will not really change the settings for this handle variable because the variable is static and it will not be changed if the parameters of the program are changed. And yeah, for this reason, it's not a good solution for live trading accounts. But if you want to use it in a strategy tester only, this might be a good solution to keep everything clean. Another solution would be to not create the handle here, but instead, let me just take it from here, but instead create a variable for this and make this variable, or call this variable, for example, handle MA. If I compile this, you can see now I cannot compile this here because now we have to provide a parameter here. But what we could do is in our main program, we can now create this handle. And now we can actually set the value in the onInit. Like this. So if we now do it like this and now pass this handle here to our MA filter function, this should also work. And now, oh yeah, we cannot really choose, or we should not use the same name. Let me just call this HMA here. Handle MA, and now it should also work. Like we can run the program and you will see that it now still works. And the good thing is that now our handle can be, or the values here could change if you, for example, create a bunch of input variables for this and use these input variables, because then in the onInit function these values change. Like let me give you one example. Input, we can say MA periods. We want to make this like 100. Should be a int. We can have input enum time frame. The overall time frame for a program could be period H1. And now we can use all of these things here. MA periods like this. And we could also, for example, use the time frame here for our check flag function now. And we could also say we want to make the bars here a input variable, flag bars, for example. So this still works, of course. Input int flag bars could be 4 or 5 or whatever. And yeah, I could also define like the mode for the MA enum MA mode method, MA mode or method MA mode SMA. And then we can say input enum applied price, MA applied price, price close, for example. And now I can use all of these input variables here. And this makes sure that that they are changed correctly, and we always have the correct values here, and our handle uses the correct values. And since it is in the on init now, it also changes if the user changes the settings. So yeah, I would suggest that we also add like the symbol and the time frame here, since we started doing this like this. And then, for example, let me show you another solution or another thing you can do, which is we can, for example, say like if you think this is a little bit ugly because now you have or you create the handle here in this file, but you then use it pretty much in this check MA filter function, you could also go ahead and delete it from here again. And you could say, for example, you want to do it again in the check MA filter function, and you still want to make this a static variable, so it's not processed every single time. And now you can use the symbol here and the time frame from these parameters, and you want to have like this is no longer needed. And then you want to have the MA periods, MA method, and MA applied price still from the inputs. Then you kind of have to create some parameters for this. Periods, MA method, and MA applied price, for example, like this. This is, oh wait, this is enum applied price, this is enum MA method. And then you can just use these parameters and MA applied price. So if we do it like this, yeah, this is handle MA now again. Now we still have, or we again have the problem that this is not done, this is not updated in the onInit. But what we can do is, for example, we can create one more parameter here, and we can say, for example, bool is create handle. And by default, we could say this is false, or is update handle. And then by default it's false, but we could say, for example, if is update handle, like this. Like if this parameter is true, then we want to update the handle. Then we want to say this should be recalculated pretty much with the values from this parameter list. So what this helps us with, oh yeah, let's exchange this also. What this helps us with is that now we can use this check MA filter function to first of all create the handle and also get the values. So now we could say in the onTick function we still use the check MA filter function. And we now provide, of course, all of these parameters, like the symbol, the time frame, the MA periods, the MA method, the MA applied price. So we take all of this from our inputs here. So we covered this. And now, if I compile this, I mean, this would work. But this is not updating the handle. And I would not want to update it here, because as I said, we want to get it out of the onTick function. But now you can have or you can call the onInit, the check MA filter function here also in the onInit with these parameters, time frame, MA periods, MA method, MA applied price, and now we want to say update is true. And yeah, if we compile it, it works just fine. So yeah, let's just add some more functions to our include file. So we handle the MA filter. So let's have a look at, for example, trading stops. Trading stops is something you might want to use often, but you don't want to write the code for it every single time. So you could create a function like void trailing stop, and here you have the like normal code that we do have in a trailing stop function. You just go through all of the positions, I minus minus, and then we do need to select a position, and here I like to use the C position info class, and this class is part of the trade.mqh file, which we can find here. And if we include this, you can see now in our my library file we include a bunch of other files, and this is taken from this path here, and we know where to find this file because we have to go to the trade folder here in our include folder and then find the trade.mqh file. And you can see this is just another mqh file. It holds the definition of a class, and this is the class that we can now use. So and also all of the other files and classes that are included in this trade.mqh file. So I can now use, for example, the C position info class. And also, if we now compile our flag trader program, you can see all of these files from the trade.mqh file are now also included here because we get them because of the include of the flag of the my library file. So we include my library, and my library includes a bunch of other files. So in our flag trader YouTube program, we now have all of these files pretty much. So here, yeah, we now have this object here, and we can now use it to select a position by index, for example. And if we were able to select a position, then we could, I mean, here you could also, of course, say you want to have the symbol as a parameter and maybe also a magic number. And now we can say if position symbol is unequal symbol, then we want to continue and do not process this position anymore. And we can say if magic, let's say a default value is -1. So if magic is greater than -1 and position magic is unequal magic, then we also want to continue. So we give the user two options. We can either say magic number is -1, then we want to process all of the positions, or we define a specific magic number and then we only check the positions with this specific magic number. And then next we can say we want to have a bunch of other inputs here. Let's say, for example, we can make doubles, TSL trigger percent. We can have TSL percent and TSL step percent. For example, these are some standard parameters that you might want to use for your trailing stop. So what we can do here is if let's also get the bid price and ask price for our currently selected symbol of this position. So we say symbol info double, position symbol and symbol bid, and then we also get the ask price, symbol info double, position symbol ask, and now we can check if the bid price is above position price open plus position price open multiplied with the TSL trigger percent divided by 100. So we check if the trailing stop trigger is already reached, and if so, we want to calculate the new stop loss, which will be the bid price minus bid multiplied with TSL percent divided by 100. And I mean, you maybe want to round this also to a precision of digits. And then we should also get the digits here. Digits for our current symbol here. Symbol info integer, position symbol digits, like this. So we get the digits here, so we can round this. And then we can check if SL is greater than position stop loss plus position stop loss or position price open. I mean, I don't know how you want to do this calculation, but yeah, we also have to process or calculate with our TSL step percent multiplied with TSL step percent, and this can be, I mean, it can be based on the position stop loss, the position open price. It really depends on what you want to do, but this is just how to do it in general. And if our trading stop loss trigger is reached here, then we calculate the new stop loss. We check if the new stop loss is at least the TSL step percent greater than the previous stop loss. And in this case, we create a trade object, and we can use this trade object to say trade position modify, and then for our position ticket, we set the new stop loss and the old take profit. And that's basically it. Oh, I think, wait, no. Default value for parameter. Double. Why do we need the default value? We don't. Oh yeah, because I said this. Yeah, if you provide default values for one of your parameters, it has to be at the end of the parameter list. So we would have to move this to the end of the list, otherwise there's a problem. So let's move this here. And that's basically it. So if we move the magic to the end of this parameter list, it works just fine. And then we have one warning left. It says that there's an implicit type conversion. But yeah, we are pretty sure that the digits, the amount of digits is an integer value, so we can just typecast it here. So if we compile this, this is done for the buy positions now. So we also have to do this for the sell positions, of course. So we can check if, oh wait, first of all, we have to check if position type is equal to position type buy. Then we want to process the stuff for buy positions. And if it is a sell position, position type is equal to position type sell. If it's a sell position, then we want to check if ask smaller than position price open minus position price open multiplied with TSL trigger percent divided by 100. So if our trigger is reached, we calculate the stop loss. And here we say ask plus ask multiplied with TSL percent divided by 100. Then we round this, SL and digits. And then we check if either position stop loss equal to 0 or SL is smaller than position stop loss minus position price open multiplied with TSL step percent divided by 100. So this should be all we have to do to find a new stop loss for a sell position. And if everything is true, then we want to modify our sell position with a new stop loss, and we keep the old take profit. So this is a basic example for a trading stop loss, and since we have this in this trading stop loss function now, we can use it in our flag trader program, or in any program actually that includes the my library file. So here we can do for example trading stop for the current symbol, and then we have to provide the TSL trigger percent. I don't know, let's say, I mean, usually you want to make inputs for this. TSL trigger percent is like 1, for example, TSL percent 0.5, for example, and then TSL step percent 0.05, for example. And then we can use all of these parameters here. TSL trigger percent, TSL percent, and TSL step percent. And we could say we want to define the magic number, or we just keep it as -1, and then it should process all of the positions here. Talking about positions, we can also, and this is a thing I would always recommend, is we can also create some functions here that help us to open positions. For example, I usually like to create a execute buy and execute sell function. So for example, you could say execute buy, or let's make this a unsigned long, or a long, execute by function. And then we also want to have like the symbol, for example, here, string symbol, and we want to have a SL%. We want to have a TP%. And we can have default values for this if we don't want to have a SL and a stop loss. And then we can say, of course, also the magic number. I think -1 doesn't work because we always have to provide the magic number. So what we can do here is now we can say we want to calculate the position or the values for our order. So we can say the entry should be for a buy position, symbol info double, symbol ask. Then we can round this. Entry is equal to normalized double, entry digits. Now we have to get the digits again. In digits is equal to symbol info integer, symbol digits. And then we calculate the stop loss. And here we say SL is equal to entry minus entry multiplied with SL% divided by 100. And then we can also round this. And then we calculate the TP, which is for a buy position above the entry price. So entry plus entry multiplied with TP% divided by 100. And then we say if or TP is equal to normalized double TP digits. And now we can just open a new position using a new trade object. And then we can say trade buy. And yeah, I've write this execute buy function now to just handle market buy positions. You could of course change this so you can also do everything else. And also I want to define the lot size here. So let's say, yeah, we have to provide a lot size. So this, I would not provide a default value for this. And then, yeah, let's just use the lot size from here. So volume is the lot size, symbol is the symbol, price is the entry price, SL is SL, TP is TP, and a comment will be, yeah, we don't want to place a comment, but we can say set expert magic number, and here we provide the magic number. And this will create a buy position. And then we want to return a value, and the return value will be trade result order, I think. This will be the ticket of the order that we just sent. And yeah, let's make this unsigned long. And yeah, so this is how you can create an execute buy function. And now it's very easy to just take this, copy it, and write a execute sell function, right? So parameters are pretty much the same. Calculation is a little bit different because we want to open at the bid price, of course, symbol bid. Then the SL is above the entry price. The TP is below the entry price. And the rest pretty much the same, but we open a sell position. So if we compile this, we now have the execute buy and execute sell also in the library file here. And you could add more stuff, like for example, a calculate lot size function is a very typical function for such an include file, but I don't want to do it in this tutorial. This is something you can do yourself. I mean, I just do this to show you how it's done theoretically, so you can create your own MQH file and add all of the functions that you really need, because I don't know what you need and what you want to have in your own include file. But yeah, so far we just added this execute buy, execute sell, check flag, and yeah, check MA filter and trailing stop. And now let's have a look at how we can use all of this in a program to make a working program with very little code. So first of all, we want to say we create some more inputs. Double for the lots, for example, 0.1 lot. Then we say double SL% will be, I don't know, 1, or let's TP percent. Yeah, let's just make it 1. And then, oh yeah, we have the TSL trigger here already. Let's move this up here, and it's getting a little bit messy, so we could create some groups here. Group, general settings, and then we can have, for example, input group, signal settings, and we could have a group for filter settings. This will make it look a little bit more structured. And then, yeah, we get our we update the handle here in the onInit. Then in the onTick, we check for a new bar. And here we check the flag, the MA filter, we process the trading stop. And now we, of course, also have to open the positions here. So what we can do is we can say if flag is greater than 0 and MA filter is greater than 0, for example, we want to say execute by. And if flag, it could also be a else if, it doesn't really matter here, smaller than 0 and MA filter smaller than 0, then we want to execute a sell position. And that's basically it. So if we compile, wrong parameter count, of course. So we have to provide the symbol here, the lots, and the SL percent, the TP percent, and the magic number, but we don't have a magic number for program, so I will leave this blank. So lots, SL percent, TP percent, and now we should be able to compile. There is one typo here, but if I fix this, we can compile. And you can see this, our main program, our main expert advisor is actually very, very clean. We have a bunch of inputs, and this is always necessary in the experts file, because yeah, it kind of makes sense. Actually, I don't know if we can. I think we cannot move this. I think if we move it here, it will not be visible. Yeah, let me check this. If we go check the flag trader now. Oh, we do see the lots actually from the input file. So we could have the inputs in the my library, but I think it's not really what you would see often, and I think it's not really recommended. So we have a bunch of inputs in our expert here. Yeah, update the MA, check for a new bar, and then check the position opening. And it's like 50 lines of code. So the main portion of our code is really in this include file. Here we have 100 lines, but still we can easily understand what the flag trader program is doing. Oops. Because, I mean, inputs are pretty self-explaining. Here we could write a comment, update MA handle if necessary. And here we can check for a new bar. So if we add a bunch of comments, we still completely understand what's going on. Check for bull or bear flag, check MA filter, and then, yeah, process trading stop. I mean, it's very easy to understand. And it takes literally no code to create programs very quickly if you have such an include file. And your include file, by the way, it could be very long. It could be like 1,000 lines of code. In this case, I mean, it would make sense to restructure it, maybe make it more efficient, maybe create a class around this so you don't import or use all of the functionalities every single time, because it will make your main program inefficient. But you could make the library very, very big if you want to. But yeah, let me show you in the end now how this looks like if I activate another test. So you can see we are testing this program now, and I don't know where my... Oh, I'm using the H1 chart here. But it's not really perfect, because I think here I use period current, which will make some problems. So I also use the time frame now for the timestamp, so we don't see too many positions. But yeah, let me fast forward. So here, for example, we do have a sell position, and it's correct because we are below the moving average. There was this bear flag, and we opened the sell position. So now if the market goes into profit, Actually, I don't know where my trigger is for the trading stop, so we can see if this is also working. Ah, yeah, this doesn't really make sense. So let's change this. Let's say, for example, we want to make the SL percent 5% and TB percent also 5%. So we can see the trading stop loss in action, hopefully. So if I start this, this test again now with the new settings, let's wait for a position here, fast forward. Oh, invalid stops. Yeah, this is a problem actually, because I am trading futures here, so I think there's some problem with my calculation, because with futures you cannot really trade every price because of the tick size. So in this case, if you want to trade futures, you will have to change this. You cannot just use normalized double, but instead you will have to write your own rounding function, so it really respects the tick size of your symbol. But yeah, we still see a position here, which is great. So let's see if this position goes into profit, if the trading stop loss will modify this position. I mean, hopefully it goes into profit. And yeah, okay, there was the modification. I think it happened when the program was around 1% in profit. Yeah, should be just fine. But you can also test this on your own end, on your own PC, if you just copy the code here. And if you do not work with futures, it's just fine. You can use it like this, because normalized double is usually fine for CFDs and Forex. So yeah, this is how you can create your own MQH file, put a bunch of functions in it, and then use it in all of your programs. Because now I could use this my library file, I could include it to all of my programs, and I quickly have access to a trading stop, I quickly have access to a execute buy, execute sell function, to the flag function, to the moving average filter, and stuff like this. And this was a very basic tutorial. I mean, there are lots of ways to include the functionality or the efficiency of this program. Yeah, let me just name one or two things. For example, like with the handle, you could probably find a better solution for this. Or for example, here for the trading stop, we loop through all of the positions. So for example, if you create multiple different trading stops, you might want to do it all in one loop, or you want to find some other logic so you don't process too many stuff with every single tick. But yeah, this is nothing I want to cover in this video. In this video, I just want to show how in general it works, and I hope I was able to show this. As always, I will upload the code of this programming tutorial to the school community. So if you're not part of the community, you can join and download it from the community and then play around with this library, and of course modify it so you can make it your own. Okay, that's it. Thanks for watching. Have a great time. I will see you next time. Bye.